Good evening, and thank you for joining us. Tonight, we take you deep into the heart of the Amazon rainforest, one of the most important ecosystems on Earth. Known as the lungs of the Earth, the Amazon spans over 2.7 million square miles across South America and is home to many plants and animals, many of which are found nowhere else in the world. The Amazon's rich forests, thick trees, and winding rivers provide homes for many creatures. The sloth, for example, lives in treetops, moving slowly and blending in to stay safe from predators. The jaguar, a strong predator, prowls the forest floor using thick plants to hide while it hunts. In the river, the pink dolphin swims through the river, perfectly suited to life there. All of the animals depend on the forest to survive. But the balance of the Amazon is under threat. Deforestation, illegal mining, and climate change are destroying parts of the rainforest. These activities harm animals and plants, and they also reduce the number of trees that help absorb carbon dioxide, which makes global warming worse. Protecting the Amazon is something we all must do. We need to support efforts to stop deforestation, promoting farming that doesn't harm the forest, and help the Indonesian communities who have lived there for centuries by making choices like buying products that are grown sustainably and supporting groups that protect the Amazon. We can make a difference. The Amazon is not just a home for animals. It is essential for our planet's health. Let's work together to keep it safe for the future generations. Yes, I do feel that we should work with the Indonesian people to help us and to guide us into ways that help us to be able to preserve the Amazon rainforest, which is a vital geographic feature that is vital for the plant's health. Reporting live, this is Kyler, aka Zaire. Back to you, Kayla.
Thank you, Kyler. Hi, I'm Kayla, and today I will be giving you information about the tundra. The tundra is located in the high latitude parts of the northern hemisphere. One thing the tundra is known for is permafrost and cold climate. If you ever think about going to the tundra, make sure to bundle up. Trust me, I never been, but I heard it gets very, very cold. The climate in the tundra gets very cold, windy, and the rainfall is scant. It experiences temperatures from negative 28 degrees Celsius to negative 34 degrees Celsius in the winter. That's colder than the average winter. The tundra also has penguins, seals, rabbits, and albatrosses. Ecosystems in the tundra store vast amounts of carbon in the frozen permafrost. They also provide a habitat to caribou, Arctic foxes, and snowy owls. Tundra, warm air rises from the ground and cooler air sinks, creating wind patterns. Terrain, including hills and valleys, can also affect the movement of convection currents. Heat transfer in the tundra is largely restricted to the near surface layers. Frozen tundra is found below the ice caps of the Arctic, extending from North America all the way to Siberia in Asia. It's also known for its large stretches of bare ground and rock. The tundra also has treeless regions. In the tundra, extremely cold temperatures cause dense cold air to sink towards the surface while slightly warmer air rises. Did you know the tundra has some of the coldest temperatures on Earth, dropping as low as negative 50 degrees Celsius in the winter?
Good afternoon. My name is Valeria Bautista, and I'm reporting from the Amazon rainforest. Today, I'm going to take you on an exciting journey through one of the most amazing places on Earth, Amazon rainforest. Located in South America, the Amazon covers most of the entire Amazon basin, and it is huge. It's about 2.3 million square miles. That's bigger than the entire United States. Not only is it massive, but it's also home to some of the coolest and most dangerous animals on the planet. Oh, and did I mention it holds the second largest river in the world? That's right. The Amazon River flows right through this incredible rainforest. What makes the Amazon so special? Well, it all comes down to climate and geography. Let's start with the rocks, because believe it or not, they play a big role in how everything works. The Amazon sits on these two giant shields, called the Guiana Shield and the Brazilian Shield. These shields are made of really old rocks, like granite and other materials that are billions of years old. These rocks help shape the land and the water that flows through it. Next, let's talk about the climate. The Amazon is a tropical rainforest, which means it is warm, humid, and rainy pretty much all year. The temperature stays between 77 Fahrenheit and 86 Fahrenheit, and it rains a lot, up to 3,000 milliliters every year. Why does it rain so much? Well, it's all about convection currents. When the warm air rises up from the forest floor, it cools down and turns into water, causing heavy rain. Pretty cool, right? But that's not all. The wind plays a big role in all of this. Winds from the Atlantic Ocean bring moist air to the Amazon. When this moist air hits the mountains, it gets pushed up, and that causes more rain to fall. Plus, trade winds and westerlies in the ocean helps move heat and moisture around, which changes the rainfall patterns in the rainforest. The geography of the Amazon is also super important. Mountains in the region cause uneven rainfall. Some areas get lots of rain, while others stay dry. In some valleys, cool air gets trapped, which leads to big temperature changes. Coastal areas near the ocean get more consistent rain and milder temperatures, while inland areas are hotter and drier. And don't forget about ocean currents. The Atlantic Meridional Overturning Circulation, AMOC, is a system that moves warm and cold water across the ocean. This helps control how much rain the Amazon gets, either by bringing more rain or less, depending on the temperatures. So as you can see, all these things, convection currents, wind, ocean currents, and the land, work together to create the perfect environment for the Amazon rainforest to thrive. It's this combination that brings the heavy rainfall, high temperatures, and humidity that keeps the forest so alive and full of plants and animals. But here's the thing, even though we know a lot about the Amazon, it's still a mystery in many ways. With its vast size and complex ecosystem, there's so much still we don't know fully understand. So even though we're learning more every day, there's always something new waiting to be discovered in this wild, beautiful place. I'm Valeria Bautista, reporting from the Amazon rainforest. Thanks for tuning in, and remember, science is always full of surprises.
Hi, my name is Michaela Bailey, and I'm here to inform you about the Great Barrier Reef, also known as the GBR. Off the coast of Queensland, Australia, in the Coral Sea is the Great Barrier Reef. Among the Great Barrier Reef's geographical characteristics are the Great Barrier Reef encompasses 344,400 square kilometers and is home to 3,000 coral reefs, making it the biggest coral reef ecosystem in the world. The Great Barrier Reef's 600 continental islands and 300 coral cays are additional geographic characteristics. Additionally, there are 150 inshore mangrove islands on the Great Coral Reef, a living coral or algal framework, and only one component of the complex of features that is the coral reef. In summary, the GBR's long-term climate and short-term weather are influenced by the interaction of wind patterns, ocean currents, rainfall, and climate cycles. Ongoing changes in global climate systems have the potential to modify these processes and the reef's long-term health. All things considered, the GBR's climate is shaped by these geographical factors, which together produce a dynamic weather system with distinct wet and dry seasons and encourage the formation of coral reefs and other marine ecosystems. The GBR is one of the planet's most biologically rich and diverse marine habitats because of the mix of mild temperatures, considerable rainfall during the rainy season, and the coast's moderated influence. For example, in the GBR region, ocean currents play a key role in determining both long-term climatic trends and short-term weather patterns. These currents help form the coral reef ecosystem, making it resilient and more favorable conditions and vulnerable to climatic fluctuation by affecting water temperature, nutrient availability, and the frequency of extreme weather events. In conclusion, a tropical humid climate is produced along the GBRs by a In conclusion, a tropical humid climate is produced along the GBRs by a confluence of warm, steady temperatures brought on by ocean currents, especially the EAC. Seasonal rainfall patterns and the moderated influence of mountains and coastal features. Rich biodiversity is supported by this climate, but the reef is also susceptible to the effects of ocean temperature variations, and climate variability, like El Nino. Warm waters and heavy rainfall during the rainy season in the area create the perfect circumstances for coral growth, but maintaining reef health in the face of shifting weather patterns also calls for careful balancing.
Hello, my name is Blaze Roberts. The region that I'm going to be talking about today is the Sahara Desert. The Sahara Desert is located in northern Africa. The basic geographical features of the Sahara Desert includes large areas of rocky plateaus, plains, and flat-top rock formations. There are also many mountain ranges within the Sahara Desert, and many are volcanic. Approximately 25% of the desert consists of sand dunes, with some of the sand dunes exceeding heights of 500 feet. The Sahara experienced two primary climate regions: a dry subtropical climate in the northern region and a dry tropical climate in the southern region. The dry subtropical climate is distinguished by exceptionally high annual and daily temperature variations, featuring cold to cool winters and hot summers, along with two peaks in precipitation. The Sahara Desert ranks among the driest and hottest areas globally, often experiencing mean temperatures exceeding 30 degrees Celsius or 86 degrees Fahrenheit. During the summer months, average high temperatures consistently surpass 40 degrees Celsius or 104 degrees Fahrenheit for extended periods, with peaks that can reach as high as 47 degrees Celsius or 117 degrees Fahrenheit. Precipitation in the Sahara Desert is limited, with the entire region typically receiving less than 100 millimeters or 3.9 inches more of the rainfall annually, with the exception of the northernmost and southernmost peripheries, as well as the elevated mountain areas within the desert.
Good evening. My name is Harlan Granger, and today I want to share with you what I've learned while working on a fascinating project about the California coast. This experience has been incredibly informative, uncovering cool facts, breathtaking geographical features, and amazing places to visit along the coastline. It's truly been an eye-opening journey, and I'm excited to share some of the highlights with you. Let's start with the basics. Did you know that the California coast stretches over 840 miles? This incredible expanse offers a striking blend of diverse geographical features, from the sweeping sandy beaches of Southern California to the towering Santa Lucia and coastal ranges. One of the most iconic features I discovered is the Sur Cliffs, where massive cliffs plunge dramatically into the Pacific Ocean. But this project wasn't just about physical geography. I also delved into the fascinating science behind the region's climate. I learned about convection currents in the atmosphere and how they play a key role in shaping California's weather patterns. For example, global wind patterns interact with geographical features like mountains and large bodies of water to influence the local climate. These interactions affect temperature, and precipitation, and airflow along the coast. It's incredible to think about how all these elements work together to create the climate we experience here. This project has given me so much more information than I could have imagined, and I now have a deeper appreciation for the natural beauty and complexity of the California coast. Whether it's exploring the sandy beaches, marveling at towering cliffs, or understanding the science behind the weather, there's so much to learn and discover. Thank you for listening, and I hope you enjoy hearing about what I've learned as much as I've enjoyed sharing it with you. And once again, thank you.
California's coastline stretches over 800 miles, featuring diverse landscapes like the dramatic cliffs of Big Sur and the sandy beaches of Southern California. Iconic cities such as San Francisco, Los Angeles, and San Diego blend urban vibrancy with unique oceanic beauty. The Pacific Ocean shapes the region's identity, supporting marine life, recreation, and scenic vistas. The coastline experiences a Mediterranean climate with mild winters and dry summers. Northern areas like San Francisco are cooler and foggier due to ocean winds, while southern regions such as Los Angeles enjoy more sunshine and warmth. Ocean currents and atmospheric flow create unique weather patterns by moderating temperatures and controlling rainfall distribution. Convection currents in the atmosphere and ocean help balance heat and moisture across the coast. Warm air rises and cools and moves toward higher latitudes, while cold air sinks. These currents help regulate California's seasonal weather, providing consistent patterns of temperature and precipitation. Global wind patterns and ocean currents further influence California's coastal weather. Westerlies bring moisture inland from the Pacific, while trade winds drive warmer waters toward the coast. Coastal mountains shape precipitation by creating wet windward sides and drier leeward sides, enhancing the region's climate diversity. The coast's geography plays a vital role in defining its climate. Mountains, valleys, and the ocean interact to create microclimates, where cooler summers and milder winters prevail near the coast. Inland areas experience more extreme temperatures due to the lack of ocean moderation, while valleys can trap heat, creating warmer conditions in localized areas. The California current, a cold ocean current, significantly impacts coastal weather by keeping temperatures mild and summers drier.